factoring polynomials. Yesterday we did the first objective, which is using the factor theorem to determine the factors of p of x. Do you guys remember how we determined whether or not it was a factor of the polynomial? Yes, when you did synthetic division, if what was equal to 0? The remainder. So if the remainder was 0, it went in there evenly. Great. Today we're going to factor polynomials by grouping. So this means we're going to have polynomials with 4 terms. And we have to use something called grouping. And then we're also going to learn 2 new special patterns. The sum and the difference of 2 cubes. Okay? When we were doing factoring the first time around, do you guys remember what the first rule of factoring was? What you'd want to do? Yeah, the greatest common factor. So we talked about, remember, the first thing you want to do is find out what you have in common. Okay? Then you're going to look for those special patterns, and then we do the guessing and checking. So today we are going to have some special patterns here. By grouping. So we're going to go to the bottom of your page here for the factoring by grouping. Okay? Okay, so if you have a polynomial with 4 terms in it, okay, a polynomial with 4 terms, you can use a process that is called grouping, and there's 4 steps to it. The first one is make sure the equation is in standard form. That should happen most of the time. Okay, so remember you start with the highest exponent and then it decreases. Okay, and then the first thing that we're going to do is group the first 2 terms and the last 2 terms together using parentheses. And then we're going to do that first step where we're looking for the greatest common factor. And then once you factor out those common terms, those monomials, you are going to use the distributive property to rewrite the expression. And in order to do this, you have to have the same factor inside your parentheses. Okay? If the factor is not the same, then you cannot factor by grouping. Okay, so then you would not be able to factor it by grouping if you do not have the same thing inside the parentheses. Okay? Alright, so when you're ready to start factoring, let's flip over our sheet and look at example 2. Okay, and we're going to be practicing lots of factoring today, so some of it's going to be like the new special patterns that you guys have here. Sometimes you might have to use some strategies that we've learned in the past. And we're going to be doing some practicing with that today. Okay, so if you run into a problem, you can ask me. Yeah. Grouping. Yep, so if the factor is not the same, then you can't factor by grouping. Yeah? Okay, so for example 2, why don't you guys go through and see if you can do the first couple steps. So make sure the equation is in standard form. Does it go in decreasing exponent order there? Okay, two terms. And then you're only going to look at the first two terms to see what you can factor out, okay? So I have x cubed minus x squared, and we are going to group those two together. And then don't forget the sign in front. That should be the negative 25x plus 25. Okay, so after you do the grouping, you have to take out the GCF. So you have x cubed and negative x squared. Okay, so in this one, we can only take out variables. Do you guys remember what you take out? How many x's? 2. So the most you can take out is the smallest one. So if you take out x squared, remember, what we're doing is the distributive property. It's just backwards. So you're dividing. What is x cubed divided by x squared? X. What is negative x squared divided by x squared? Negative 1. Okay, so this is your first part. Okay, now we're going to look at this one. So I have negative 25x and a positive 25. So this one has an x, this one does not, so I cannot take out a variable. Now, remember in the directions it said we want these to match. So if I want this to be a positive x, I'm going to have to take out what? Negative 25. So this will be negative 25. And then will you guys put what goes inside the parentheses? I'll give you a few seconds to do that. Okay, and then Dylan, tell me what you got inside. Yeah, good. Okay, so negative 25x divided by negative 25 is x. 25 divided by negative 25 is minus 1. And then look, these two match. That's what they should do. Okay, if they match, what you can do is you can take that out of both of them. So what happens is if you take out, and I always put the second, I'll show you why. Okay, so if they match, you can take the x minus 1, and then this is what's happening. You're taking an x minus 1 out of this whole term. So if you take out an x minus 1, you're left with an x squared. And if you take out a negative an x minus 1 here, you're left with a negative 25. Okay, and I'm just going to write this here because we are going to do another step. So x minus squared minus 25 times x minus 1. You don't have to write this next part down. I just want to show you where this is coming from, okay? So I'm going to show you this in a couple different ways. So what's happening here is you have x squared times x minus 1 minus 25 times x minus 1. So when you are taking this out, when you take out the x minus 1 from this entire thing, okay, you're left with the x squared. When you take out the x minus 1 from this whole thing, you're left with the minus 25. Now, let's think of this like we did last week. Remember how last week we were doing the multiplication? Okay, we're doing it with multiple terms. Basically, if I did that here, I would have x squared times x minus 1, and you don't have to write this part down. I just want you to recognize that this is what we did last week. Remember how we did x squared and we would distribute, and then we would take the second one, minus 25, and distribute? That's exactly what we're doing, but in reverse. Okay? So this is what we have here. It's the same thing. It's just we're rewriting it now. Okay? Alright, so once you do that, you have to check and see if you can factor further. Okay? So once you get here, you have to ask yourself, can you factor more? Sometimes the answer is yes, sometimes it's no.
Okay, now the x minus 1, I can't factor that down anymore. I don't have a GCF. I don't have a special pattern. But what about x squared minus 25? Yeah, what's that? Yeah, what, do you guys remember what the pattern's called? Difference of two squares. Oops, gotta put my S in there. Sorry, I snuck it in there. So remember the difference of two squares is a squared minus b squared. You can factor that into a plus b times a minus b. Is that ringing any bells? It's when you have perfect squares, right? So if you were to break this down, this is going to be x plus 5 times x minus 5. And then the x minus 1 just drops down because that's still there. And this would be your final answer. Okay, and then I want you to try part B. Okay, so this is the difference of two squares. If I were to FOIL that, x times x is x squared, plus 5x minus 5x would cancel. 5 times negative 5 is negative 25. Okay, so let's try part B. Alright, you guys, it looks like you guys are doing a good job at picking out the GCF. So you have the 2x cubed and x squared, okay, and Danny, what'd you factor out of that?
X squared.
Good, so what do you have left inside the parentheses?
2x plus 1.
Good. Okay, so remember, you're just dividing. 2x cubed divided by x squared is 2x. X squared divided by itself is going to be plus 1. Okay, and then Yetta, what did you take out of the second one?
4.
Good. And then, so I just saw a couple people do this. If it's a positive 4, put your plus 4 here. And then if it was negative, you put the minus 4. All right, and then Yetta, what did you have left inside?
2x plus 1.
Yay, we have a match. Okay, it's always exciting when you get a match because then you can rewrite it. And then, Aurora, can you tell me how you're going to rewrite this one?
X squared plus 4 and 2x plus 1.
Great.
And then we can factor in more.
Okay, so now we're going to see if we can factor more. So we have the x squared plus 4, okay? So with the difference of cubes, if we tried to break it down into x plus 2 times x minus 2, let's FOIL this, okay? So if we tried to break it down like this, it would be x squared plus 2x minus 2x minus 4, and then the 2x and the negative 2x cancel, but this one would be minus, right? Okay, what if we tried to break it down into x plus 2 times x plus 2? Okay, we got to check it with FOIL, okay? So do this with me. Okay, so x times x is x squared. In the middle, you'd have 2x. On the outside, you'd have 2x. And then, yep, 2 times 2 would be 4. But are these going to cancel out? No. This would be x squared plus 4x plus 4. So are we able to break it down if it's the sum? Nope. Okay, so, and this is just a common thing that people will try to break down. So you can simplify the difference of two squares but cannot factor the sum. Okay, so like I said, this is something that people get confused on sometimes, which is why we're doing that out together. Okay, so if it's the sum of two squares, you can't break that down any further, which means this is going to be your final answer. Okay, you always want to check though and make sure you don't have like a GCF, okay, or special patterns. Okay, so we don't have the GCF here. No. Pattern. No. Okay, so we can't break that down any farther. Okay, but those are the two main things that you could look for here. All right, questions for me about the factoring by grouping? All right, we're going to learn some new special patterns then. Okay, so the main special pattern we talked about before was all about perfect squares. Now we're going to learn about the sum and difference of two cubes. Okay, and don't worry, we'll generate a list of cubes, so if you're not familiar with them yet, after we practice this, you will be. Okay, so the sum of two cubes has a special pattern. So if there's a number cubed plus another value cubed, you can break it down into the factor a plus b multiplied by the factor a squared minus ab plus b squared. And then if you have a difference of two cubes, you'd have a cubed minus b cubed. Okay, and a and b are just going to be either numbers or variables or a mixture of both. And this would be the factor a minus b times the factor a squared plus ab plus b squared. Okay, so what I want you to do is I want you to look at those patterns and see if we can recognize any patterns in the pattern. Okay, so what are things that we notice? Yeah.
When it's adding, the AB will be negative, and when it's subtracting, the AB will be positive.
Yeah, so if you're adding here, right, in the second factor, that'll be a minus, and then the opposite happens here. If this is a minus, this one will be a plus. Good, what else? What else about the signs? What about in the first set of parentheses? That in the first set, they're the same. So if it's plus, this is plus. If this is minus, this is minus. And then, like, these two are opposite, right? So if this is a plus, this one's a minus. If this one's a minus, this one's a plus. But notice how the b squared is always a positive? Why? As my 4-year-old nephew would say. Why? Yeah.
Because the number squared is always positive.
Yes. Whenever you square a value, it's always positive. Whether it's a negative number, that negative times the negative is positive, or if it's positive, that's going to be positive. So b squared and a squared will always be positive. Okay? Now, when you're using these patterns, there's two things we have to make sure that we keep in mind. So the first thing is that we are still taking out that GCF first. Okay? So factor out the greatest common factor first. Okay, that will do nothing except for help you and make your life a little bit easier because you'll be working with smaller values. Okay? The second thing is this trinomial that we have here, that is not factorable. Okay, so the trinomial in the pattern is not factorable. Okay, if it is a perfect square or a perfect cube, you will not be able to break down this trinomial, so you don't have to worry about doing the guess and check part if it's that special pattern. Okay, if it's that special pattern, it's going to adhere to that. All right, so we're going to do a couple of examples together. So the first one we're going to look at is the sum. Okay, so we have 8x cubed plus 216. Okay, and then before we get started, we are going to make a list of our perfect cubes. So let's do that. Make it even with factor. So we're going to give ourselves some room here. Okay, let's talk about our perfect cubes. Actually, first, let's talk about some perfect squares. What are my perfect squares? Yep. 1, 4, 9, 16, 25, 36. Where do these come from? Multiply what? Yeah, 1 by 1. So this is 1 squared, 2 squared, 3 squared. So to do the perfect cubes, we're going to have to do 1 to the third. What's 1 to the third? 1. And then if you guys want, you can just put equals 1 to the third. Okay? 2 to the third is 8. So that's a perfect square. We're going to do this for 3 to the third, 4 to the third, 5, 6, 7, 8, 9, 10. Okay, so 3 times 3 times 3?
27.
Yay! 4 times 4 times 4? 64. I don't have those even. Well, 5 times 5 is 25. 25 times 5 is 125. 6 times 6 is 36. 36 times 6. I'm okay. 216. Yay! What's 7 cubed? 343. 8 cubed? 512. 9 cubed? Yep. And then for 10, it's just the 1 and 3 zeros. Yeah, 1,000. Okay, so these are going to be values that you're looking for. Okay? But be careful because remember, the first thing that you want to do is factor out the GCF first. So if this were me, this would be one where I probably would forget to take out the GCF and then I'd have to do it later and then it wouldn't be as fun. So let's remember that the first thing you're always going to look for is the GCF. So if I have 8 here, okay, does 8 go into 216? Let's try. What's 216 divided by 8? Yeah, did you get a whole number? 27, right? Okay, so you have to take out the GCF. So if you take out the 8, and that's your GCF, I have x cubed plus 27. Okay, so we're going to think of this as x to the third power plus what to the third power? 3, because 3 cubed is 27. So when you're using your special pattern, okay, your x is your a value, your 3 is your b value. Okay, so then looking at the sum, it's a plus b, so this is going to be x plus 3. And then I have a squared, which is just going to be x squared, minus, and that's always going to stay the minus, 3 times x is 3x. B squared is 3 squared, which is 9. Okay, and then your final answer has to have your GCF in front. So this GCF of 8 just has to go right in front there. Okay, so you just have to keep the GCF in front, and you are good. All right, let's try the difference. The difference we're going to put right here. Okay, so, yep, this is your answer. Yep. Okay, now we're going to do the difference of the two cubes. And we have y cubed minus 512. Okay, so remember, we're going to think of that as a value cubed minus another value cubed. So if it's just y to the third, we're good. Okay, and then the 512, let's go to our list. So 512 is 8 cubed. Oh, mine looks a little slanted. So this is going to be 8 to the third. Okay, so we're going to put that into our pattern. Okay? So this is your A, and this is your B. Do you guys think that you could write it? Okay, let's try it. So remember, you have the little parenthesis and then the trinomial. Okay, and then actually, can you tell me what's going to go in the first parenthesis?
In the first parentheses, would be 7.
No. So, but tell me how you're getting it.
Greatest common factor.
Oh, okay, so for this one, you won't have a GCF because you can't take anything out of the first one. So your pattern is just going to be your A minus B. And in this case, your A is Y and your B is 8.
Oh, okay.
So in the front, do you know what it'll be now?
Y minus 8.
Yep. Good. Okay, and then Jack, can you tell me what the second one will be?
That is true.
Okay, did you get the first part?
It's Y squared.
Yes. Yep, good. Yep, it's Y squared. And then this is always going to say a plus. And then, yep, your A times B will just be 8 times Y. And then what's your B squared going to be? Yep. Yep, so then this is going to be your final answer. So there's no GCF for this one. Yeah, you get that?
Isn't it 2 times, oh, I'm, no, sorry.
That's the other pattern. I think you're thinking of the, remember we did the trinomial for the perfect squares, the perfect square trinomial? That one did have a 2 in it, and it was very similar to this. Yes. Okay, so now we're going to try this one. Yeah, Ava?
So in between the y cubed and the 8 cubed,
Mm-hmm.
there's a negative.
Yep.
If a number is cubed, wouldn't that mean that it would come out as a negative?
So the minus is on the outside. So the way that we're rewriting this, it would be minus 8 to the third. So it would be minus the 512.
Okay.
And with this one, the signs are built in. So when you're doing this, that minus stays in the middle. So 8 cubed would be a minus 512. For this one, it would be, well, we had the 27, but the 3 cubed would be the plus 27.
Okay, so it would only really affect like the y minus.
The minus is only going to affect which pattern you use, whether it's the difference or the sum.
Oh.
So anytime there's a minus in between, you'll use the difference of 2 cubes, and then anytime there's a plus, you'll use the sum of two cubes. So for this one, it's the difference. Okay, let's see if they have anything in common. Do you guys know right away if 8 goes into 125? No. Okay, so 2 and 4 go into 8. They don't go into 125. So what we're going to do is we're going to say, okay, what to the third power gives me 125d cubed? 5 what? 5.
Wait, 5D.
Yes, 5d. And then minus, okay, so what cubed is going to be 8? 2. So now when you're doing your special pattern, your A value is 5D, your B value is 2. Alright, so then let's write this out. So the first part of the pattern is just your A minus B. So it's 5D minus 2. Okay, in the second part of your pattern, you have A squared. So A squared is going to be 5D squared. What's that going to simplify to?
25.
Yes, 25D squared. And then remember, if this is a minus, this is going to be a plus. And then it's A times B. So it's 5D times 2, which is what? Yeah. And then the last one is B squared, which will be 2 squared, which is 4. And then remember, you can't break this down any further. As long as you take out the GCF first, you should not be able to break these down. Okay, so then that's going to be your final answer. Alright, and then I want you to try B. Okay, so first step, take out that GCF, and that GCF hangs out on the outside. Once you take the GCF out, that's just going to go in the front. The GCF. Okay, so when you're looking for the GCF, remember that's the greatest common factor. That means you can divide both of these by that value. Okay, so you have 4 and 108. What did you guys try to take out? Okay, the 4, right? So if you do 108 divided by 4, do you get a even number, a whole number? Okay, good. And then look at your x's. If this only has one x, you can't take more than one x out. It has no more to give you. Okay, it only has one x. That's the most it can give you. This could give you 4, but because that one's a 1, you can only take out one x, okay? So when you're taking out the GCF here, it's going to be 4x, and then you're dividing. So 4x to the 4th divided by 4x is just going to be x to the 3rd, which is a very good sign when we're working with the sum and difference of two cubes. Okay? And then, Luke, what do we get when we do 108x divided by 4x? 27. So plus 27. Okay, so now what I'm going to do is I'm going to use my special pattern. Your GCF always stays in the front. And then I'm going to make my parentheses for how I'm going to use my pattern. So I have x to the 3rd plus 27. So I'd like to rewrite that both as cubes. So x to the 3rd makes x cubed. 3 to the 3rd makes 27. Okay, questions about any of these steps here? Okay, so your setup for this, you took out your GCF, that goes first, and then because this is the sum, in the first parentheses, you're going to have a plus b, and then you're going to have a squared minus a times b plus b squared, okay? So now we're going to plug these in. So a plus b, what's my a value for this? X. What's my b value? 3. Okay, so then this is going to be x plus 3. Okay, and then a squared is going to be x squared. Keep this as a minus. And then ab just means you're multiplying them together. So x times 3 is 3x. B squared is just 3 squared, which is 9. So this is your final answer. Okay, so your homework today, there's actually going to be some classwork, and that is mandatory. You have to turn that in, okay? It's the 3.4 worksheet. And then for the homework, this is graded how I usually do, where if you turn it in and you do it all, show your work, you will get points for it. Okay, and if you don't have time to do it all, or you just want to practice half of it, that's okay too. And you're going to submit those in Google Classroom. So both of them you're going to submit in Google Classroom. Okay, for submitting in Google Classroom, as I'm checking over some of the stuff, some of it is getting difficult to see, so we're going to streamline this process a little bit. So I want you to use the Google Classroom app. If that's not possible, talk to me. But I want you to use the Google Classroom app. And then here are the steps. So when you go to the Google Classroom app, you go into the assignment and you click Add Attachment. Okay? Once you do that, there is a spot where you can select your camera, and then you can select, no, it says scan what? Scan pages. Scan pages, and that's what I want you to use. Okay, and that way it just makes it a PDF. You don't have to attach multiple photos. You can take them all at one time. And from what I've heard, it's quicker. Okay, so that's what I want you to do with both of these. So I'm going to give you the 3.4 worksheet. And then we're going to go over answers to the 3.4 worksheet tomorrow. And then you can write your work on another piece of paper if there's not enough space, okay?
but you have to submit the worksheet tonight.